Hello everyone, the goal of this video is to present a ELT pipeline with DBT and BigQuery and how to show this kind of architecture in Google Cloud with DBT. DBT is a tool that allows to write and to apply some workflows on SQL. Instead of writing manually the logic in SQL queries with BigQuery, we can use a tool like DBT to have a more powerful way to apply our needed logic in SQL queries with BigQuery and so on. After this, there are two usual architecture in batch in the data ecosystem. We have the ETL, extract, transform, and load, and also the ELT, extract, load, transform. And for the ELT, the principle is to directly load the elements in the engine, for example, BigQuery in this case, and then apply directly the transform part and the transformation with BigQuery and in this case DBT. After showing the architecture of the application, it corresponds to a real-world use case. I treat the statistic for the Qatar FIFA World Cup as I showed for several videos, and we will read some raw data from an input table and then apply some transformations and business logic in BigQuery and DBT. And then we will launch our ELT application directly from our local machine. We will use, for example, Poetry from our local machine. We will create a virtual environment and install the DBT and DBT BigQuery packages, and then show how to launch our DBT application from our local machine with application default credential. And after this, we will deploy our DBT workflow and application in the Cloud Run job with a serverless approach and based on a Docker image. And then we will deploy it in Google Cloud and launch it directly from the console. And it's done for the little explanation here. Some words about me. My name is Mazloum Tosun. I am a Google developer expert on Google Cloud and also head of data and cloud at GroupBiz. GroupBiz is a freelancer group in France. If you have some questions, feel free to ask me in private messages. For all the use cases, it corresponds to real-world use cases. I published the video in my YouTube channel. Feel free to subscribe to help our work for the Google Cloud community. All the code of these videos are published in my GitHub account. And in the video description, I share all the project links. I also write the dedicated article for videos in Medium. And I am also active in social networks like X and LinkedIn, and feel free to follow me. I will, after this little explanation, I will show the diagram of the use case. I have this folder diagram, and I can show you the diagram. At the left part, as I explained previously, the Cloud Run application is based on Docker. We have a Docker image. In this Docker image, we will install the DBT packages. Then we will build and publish the Docker image in Artifact Registry. That is a repo proposed in Google Cloud. Then we will orchestrate the CI part, the CI/CD part with a Cloud Build. Cloud Build is a serverless tool for CI/CD in Google Cloud. After published the image in Artifact Registry, I will instantiate and create the Cloud Run job. The Cloud Run job is based on the Docker image. And with the command line, we will deploy the Cloud Run job in Google Cloud. As I presented in the previous video, for DBT, it's more interesting to use a Cloud Run job instead of Cloud Run service, because with Cloud Run we have these two possibilities. A service is more for HTTP requests, but a job is more for batch and jobs. And that's why here we choose to deploy the DBT workflow and application in a Cloud Run job. After deploy the Cloud Run job in Google Cloud, we will firstly launch the DBT workflow from our local machine with Poetry. Poetry is a management dependencies management tool for Python, and it's really popular. After this, we will run the DBT workflow and application with the Cloud Run job directly in a serverless approach, directly from the console. And some explanation for the use case. It's a football-related use case for the Qatar FIFA World Cup data. We have two steps, a staging step with DBT. We will read raw data from an input table. Then we will apply some clean and some transformation on the raw data. We will generate a view, and we will propose a second step, a marked step. And in this step, we read the raw data and clean data and transform the element from raw to domain data and apply business logic and transformation. And at the end, we will load all the results in a final and output BigQuery table. And I think it's good for the explanation. I will start with, we have this project. And in this project, we have a root folder called DBT. DBT contains all the logic for the DBT application and the workflow. We have two configuration files, one called DBT project with a name and also a profile and a version. The models, for the models we give a name, and we could also have give other configuration. For example, we can indicate one folder will be represented by views or tables, but to be more simple in this use case, we have a simple configuration. We can target on a profile. In this case, my profiles is here, and I can target in different environments with DBT. With output, I have the element concerning the dev environment. The type is BigQuery because behind the scenes, BigQuery is used with DBT in this use case. The authentication method is auth in this case. The GCP project and dataset and priority, we have also other configuration like thread and also the GCP project location. It's good for the configuration part. For the DBT logic, I have this folder called models. And as I showed in the schema, I have a first step for the staging. For the staging, I have the SQL query. I read the raw data. I can also access to the dataset concerned by the use case. The dataset is given here in this profile configuration file, and instead of write in an hard code the dataset name, I can directly retrieve the dataset name via target.dataset. I target on the team player stat row table. It's my input table, and then I apply some transformation because some elements are represented by strings, and I want to transform them in numeric fields, numeric values. After this, I retrieve all the needed fields from the row table, and also I calculate a Boolean to indicate if I have some statistic for a goalkeeper per team. After the staging part, I have the marked step. sorry, I forgot to, the result of this model and SQL query with DBT will be represented in a view. For the second step, I have the SQL query to transform the raw data to domain data and apply all the needed transformation and business rules. I also can give some configuration regarding BigQuery, like partitioning and also clustering. I have a partition on ingestion date to prevent some full scan in the table, and also a clustering by the team name to improve the performance when we want to read the data from the table. With this syntax ref, from a DBT model, I can target to another DBT model. I calculated the cleaned raw data. I can reference the results with ref. I create an internal view in this case. I prepare also the goalkeeper statistic in my raw data via the Boolean calculated previously in the clean and staging step. I retrieve the single elements for the goalkeeper from the internal view. I calculate all the needed fields here with the team name and also the FIFA ranking and also the total goals per team. I retrieve the statistic for goalkeeper, and then I want to calculate the top scorer, best passer, best dribblers, and so on. I show you a little bit the data. For the raw data, I have the statistic here for the players flattened for a team. For example, for Argentina, I have the statistic for the goalkeeper and also the statistic for all the players. For the domain data, I will apply a group by per team and calculate the team total goals and all the top scorers, best passers, best dribblers, and so on. Goalkeeper statistic and so on. To calculate the top scorer and best passer and so on, the logic is the same. That's why instead of repeat the code with DBT, we can create some macros. Macros are equivalent than some methods or function in programming languages. The name of this macro is build player stat. In this folder macros, I created this file, and the syntax is macro and the name of the macro. I can pass some parameters as input, and I can apply the logic here. For example, with BigQuery, I will retrieve the stat indicator, for example, the goal for the player, and then I will retrieve all the players with the top scorers per team, for example. We will sort by desk the element, and then with offset 0, I will retrieve all the top scorers per team. The logic is the same for the best passers and other indicators. And if the concerned indicator is equals to 0, we don't have result in this case. That's why we return null. I think it's okay for the explanation. I passed the stat indicator here, goal scored, and all the field that concern a player object, and it will calculate all the top scorers. I apply the same for the best passers, the best dribblers, and so on. We calculate all the needed indicators, and I apply a join between the row element and the internal view that give me the stat for the goalkeeper, and I apply the group by for per nationality and team name. The logic was explained as expected. It's okay, and we showed also all the configuration file, and we will trigger the application from our local machine and virtual environment and poetry. For poetry, poetry is a popular dependencies tool for Python, and we have this pyproject.toml, and we give the version, the Python version, and also some elements that concern the current project. I need also to give the DBT core and DBT BigQuery Python packages, and maybe also PyTest to apply some unit tests. I will empty the current data in the BigQuery table and recalculate the use case. I apply a truncate, and normally the table is empty in this case, in preview. Okay, is empty. I have all the elements, and when we install all the Python packages via Poetry, it will generate a poetry.log file, like for other tools. We can, with Poetry, launch this command line poetry install. It will install all the needed packages. In this case, it was installed previously. And then when I install all the packages proposed by Poetry, I have access to the CLI proposed by DBT. And with this command line DBT run, I can launch my DBT application from my virtual environment and local machine. But I will firstly need to be authenticated in Google Cloud. I will authenticate my local machine and my shell session in Google Cloud with application default credential, ADC. I explained the concept of ADC in some videos. Feel free to check the YouTube channel to have more elements and details on application default credential, but this command line allows my local machine to be authenticated in Google Cloud with my personal account, Mazloum Tosun. Take a few seconds, sorry. Normally the authentication is fast. Sorry. Okay, I will take the URL here and launch it. Maybe I have a connection issue. Sorry. I have a little issue with my internet connection. Really sorry. Maybe I am already authenticated in Google Cloud. I will run my application to check the internet connection in this case. But normally I am already authenticated. Okay. Yes, I have some issues here. Okay. It creates the view, and normally it will also create the final table, but it's okay. The use case is finished. No need to be authenticated again because I authenticated my local machine previously. I check the result in my table. I can refresh my table here, and normally I have access to the result. Okay. I have the result here with all the expected fields. I have, for example, the node concerning the top scorers and also the best passers and so on. I can show you the result in SQL query. Here I can apply a select star because I don't have a huge amount of data and the cost is very cheap. Yes, I have the result here in a JSON form, and we have, for example, the statistic for goalkeeper, the top scorer, and also the best passer, and so on. I will empty again the table. The use case was executed as expected from our local machine, and it's good. And I will show then how to deploy the DBT workflow and application in Docker and in a Cloud Run job. For Cloud Run is based on a Docker container, on a container, sorry. We have an official Docker image for DBT and DBT BigQuery. It's really easy to pull this image from GCR.io, for example. And then, traditionally with Docker, we have a working directory, for example, that is app, and we copy all our folders in the container. We also created a Docker ignore file to ignore some folders and files in order to be more performant with Docker. I have then an entry point, and in the entry point, I will propose the dbt run command line with the profiles dir and also the project dir that target on dbt, like for the local execution, and it's good. After this, I show the deployment part with Cloud Build. We have a step in Cloud Build based on the Cloud SDK Docker image. And then with this command line gcloud build submit, I will build the Docker image and publish this image in artifact registry, that is a repo in GCP. And then with this command line gcloud run jobs deploy, I give a job name. I target on the image published previously in artifact registry, and I need also to give the project and region, and also, for example, a service account that has the responsibility to run the job. I have also some environment variables if needed. I will then retrieve the command line from my README file. This command line will execute the Cloud Build job and publish the Docker image and the Cloud Run job that contains the DBT application. I execute the command line, and while waiting the request to finish, I will show you the GCP console for Cloud Run. For Cloud Run, we have access to two tabs. We have the Services tab and also the Jobs tabs. I refresh my tables. For the services, like I explained previously, the services are more proposed to react to HTTP requests. For jobs is more for jobs, batch, or cron jobs, and others. I think it's good here. And we have the list of all our jobs in Google Cloud, and we can access to, for example, our DBT job. For our DBT job, we have the history of executions, also the metrics. We have access to the metrics. We also have access to the logs of the executions, for example. I have some issues with my connection, sorry. And we can also access to the configuration of the current job. We have, for example, all the concerned Docker image, and also all the elements concerning the VPC variables and secrets, and also the security part with the service account. We also have access to the current generated YAML by Cloud Run. I think it's okay. I check the result. It takes a few seconds to. It remains a few seconds to finish, but maybe no need to wait for the deployment. I can directly launch the previous version of my job here, access it, and I can click on the button to execute my job. I execute my job, and I can access to my job here in view, and it will take a few seconds to instantiate my Cloud Run application, because we have a cold start, but after a few seconds, normally, the application will perform as expected. We have the task overviews here, and task 0, and normally, little by little, the task will be instantiated, and we will show the final log and the results to BigQuery.
While waiting to finish, we can check some code parts, but I think I show every element, all the needed elements, and it's good. The execution is finished here. We can access to the log, and in the log, normally we will have all the elements concerning DBT. For example, we have the view and the table, create table here, and also all the elements that concern the view and the staging step. We will check the results in the BigQuery table. I access here to the table and click on refresh and preview, and normally the data are loaded as expected. I think it's perfect. I jump again in the ID, and I think it's perfect. We explained all the DBT part, and we saw that DBT is really powerful to apply some ELT pipeline and some transformation and reusable logic with macro, and we can separate, for example, some steps with staging mark and others. And then we show how to execute the DBT application from our local machine, and then with the Cloud Run job. For the YouTube channel, feel free to subscribe to our channel to support our work for the Google Cloud community, and see you soon for the next use cases. Bye bye.